Hello guys, my name is Arun and welcome to my channel. This series is actually a series of tutorials on Fortran Hacks. Now, in this video, I'm not going to explain you guys anything program related today. Instead, I'm going to explain you guys something which I should have explained to you guys a long time ago. At least during the initial parts of the initial parts of Fortran programming. Today, I'll be explaining you guys something about file extensions and some of the significance related to file extensions in Fortran. Now here's the thing: all the Fortran files that you come across that you come across have certain extensions. Like from almost all the programs that I've explained to you guys in my Fortran programming are actually Fortran 95. Some of them might be Fortran 90, but almost all of them are Fortran 95. Okay, they go with the extension .f995. Okay, and that f is in lowercase. Okay, now that's not the only type of Fortran files that are available. There are actually different types of it based on the compiler, based on the system architecture, and based on the operating system you are working with, and based on other features. You may have to use different types of Fortran files. Okay, and even the based on the version, they kind of differ. Okay, so I thought of giving you guys an elaborate and a brief explanation as to what are the types of format files available and everything. Okay, now here's the thing. Let's start about it. Essentially, there are two types of format files available in Fortran. One is called as the fixed format file. Other is actually the free format file. Okay, now here's the thing. Now, fixed format files, they actually follow the punch card format that was used that was used as a part of the old programming practices. Now, to give you guys a full understanding of what this is, let me go open Wiki and show you guys what's happening. Now, a long time ago, before in the beginning of programming, when you have to give instructions to the computer and everything, before what they had to do is that they have to make uh, they have to make large number of papers and make some dotted lines or punches on them to indicate certain operations. For instance, take an example like this. This is actually a punch card wherein you have a large paper with so many contents written in it, with so many values written in it, and then you just make a lot of punches at regular intervals based on the row position and the column position. Now each of these punches are indicated to be zeros or ones depending on which kind of programming language or which kind of a machine you're using. Okay, and these can be converted into equivalent binary zeros and ones to give some machine instructions. So as a consequence, what happens is that this entire line can is actually a combination of zeros and ones written in machine language. Okay, and in some simplify and so what happened is that before people started writing actual program in text editors or in text editors, like how we do right now, people long time ago wrote the actual machine code using punched cards like this. And then when they started using Fortran, they kind of implement initially they didn't know how to begin with, so they started using the Fortran codes in the punch card manner. What they did is they had a similar punch card like this, and then they make holes at regular intervals, and feed instructions to it. And these are actually taken from Wikipedia. These are actually punch card images that were used in the past, and once those punch cards are made, they just uh, feed it into the computer, and the computer just processes all the zeros and ones that's present, and then does some operations like that. So if you have so even if you want to do a simple addition program, let's say, you may have to collect like thousands of punch cards, and for each punch card you have to make some machine level instructions in that regard. And that was like extremely frustrating, because imagine if you just want to add two data into a compute two values in a computer, like you have to submit like hundreds of punch cards like this, each carrying one instruction or one variable or something like that. How annoying can that be? Now that's how frustrating programming can be in the past. That's how it was in the past. So what I'm trying to say here is they kind of use the punch card system for the values. So values for so the fixed format files, they actually follow the punch card format of all programming practices, and as per that there is actually a strict 72 or an 80 characters per line rule. So in what happens is that in these in these punch cards, if you count from the left end to the right end, you will have like 72 characters or 80 characters depending on which kind of punch card you use. And in these punch cards, uh, uh, holes depending which makes holes at strategic locations correspond to certain operation code or certain machine code that does certain operation in the in the computer. So they each have their own value, so they kind of use a similar format. And when they wanted to write a text editor to begin with, they start, okay, why not let's follow the text card thing, and they said that they kind of followed that. As a consequence, for each line you have like 80 lines, 80 characters. Each line is about 80 characters long, okay, and or 72 characters depending on which punch card they used, okay. And you have only 80 spaces to write your commands, any instruction. So that's the reason why even in modern text editors, program editors, you see this line over here, this margin line over here. This is actually for this actually serves for two purposes. One, to restrict the right hand margin to 72 or 80 spaces if you're following to give you a guideline as to how many spaces you're moving. And that's also the reason why if you place cursor at any part in your computer, it also shows the line number and column number for the user to get an idea for writing fixed formats, okay, for writing fixed formats. Okay, so as a consequence, you can write only 72 slash 8 or 80 characters per line, and anything extra, if you want to write in the same line, you cannot write it. You have to push it to the next line. And then characters each character in a certain position carries some significance. For instance, if you were to write a comment, they must begin at column 1 with the C or exclamation symbol, okay. Otherwise the comments must be written after from column 7 onwards, or co- after column 7, okay. Actual commands that you have to write, they must begin after 6 spaces. That's kind of mandatory. And then one of the other condition is that you cannot use tabs, you have to use spaces. Otherwise, if you use tabs, they might throw errors as far as Fortran programs are concerned. Okay, they might throw errors, but most of the time they show some syntax issues if you use tabs. So as a consequence, they throw a lot of annoying warnings, and they're not recommended. And instead, you have to use spaces, okay, if you were to use these files. And one more thing is that the character line continuation character must be placed between columns 1 to 6, if there were any. And if you have any compiler flags or writing contents or some flags, not compiler flags, if you have like preprocessor directives or certain other commands, let's say, those are actually filled between columns 1 and 6 depending on which one you use. So it matters. So if you want to fill normal commands over there, you cannot do it, okay. And fixed format files, they have several extensions, and the most common extensions are .f and F77. However, there are other compilers which take extensions like .ftn, .for, sometimes even .fpp, something like that. Even those come into picture. And there are like two types of extensions: one with a smaller case, another with an uppercase. Okay, any one of these extensions, if you come across any Fortran file with some extensions like these, you can most they'll be most probably fixed format files. Okay, and if you want to write those, you have to follow these rules and regulations, which are kind of really stringent and picky, to be honest. And then you have free format files, wherein this punched card format is not followed. For instance, if I were to give you guys a look, this is how a Fortran file might look like if you write in a fixed format. If you write in a fixed format, you see there are like five spaces over here. There are like five spaces over here which are empty, which is intentional, and then anything you write has to be written from the seventh column. Okay, and you have like you know some from here to here, from this end to this end, you have like 80 pages, you have like 72 or 80 columns, 80 column width for each line. And then if you see, all of them begin with six pages. Instead of tabs, I mean, you can use tabs, but instead of tabs you prefer spaces. So this is how you know this is how you have to write a fixed format layout for Fortran file. Okay, this is how it might look like. On other hand, free format files, have you seen below, have you seen, that's how I mean, all the programs I've shown you guys so far are actually free formats, wherein this punch card format is ruled out. The commands can be in any position, any place, doesn't matter. They don't have the strict rigid rules like here. And this 72 or 80 characters per line rule is taken off. So even if you want to write a single line, and I mean, you want to write all the commands of a program in a single line, which can go like several thousands of columns, it doesn't even matter. But keep in mind about the readability matters. Okay, and then the positions do not carry any significance, and many other restrictions that were kept in fixed format files are removed over here. And then you can use tabs are used can be used for indenting the code properly, and for giving spaces for making it readable. They might throw a little bit warnings here and there, but are not errors. Sometimes tabs might throw errors in fixed formats. They usually don't, but sometimes they might throw. But in free formats, they don't throw any errors. Okay, so that's one thing. And there are some small changes in syntax. For instance, if you were to if I were to show you the same example, if you guys look at this in the top, uh, you know uh, most of these syntax kind of looks similar to how we define in normal Fortran, but some of these syntaxes are kind of different. For instance, the character continuation, we don't do like this in Fortran. Now in free form Fortran, we just in fixed form Fortran, the character continuation can be done with any character, and you don't need a and character or something like that. But in free Fortran, it's kind of restricted to the and symbol, like mostly and symbol and stuff. And there are a few syntax changes, and some commands are dropped, and some commands are dropped, some commands are improved. Those are some stuff. And other than that, not much. And the thing is, the advantage of free format files is, still, despite all the conditions and restrictions removed, you can still follow the fixed format style if you want. The fixed format style is kind of a little pain to write, but if you, sometimes it's very helpful. And if you it's good to follow that sometimes, depending on the case. So all the free format files have the extensions like F90, F95, F03, F08 and all. Well, the F can be lowercase or uppercase, it doesn't matter, as long as it's not F77 or just F or FTN or FOR, doesn't matter. Okay, usually all the free format files will have an extension, will have 90, 95, 03 or 08 as a part of their extensions. Okay, and there are other types of extensions, other types of files like files that allow preprocessor directives and do not allow preprocessor directives. As you guys notice, if you see my previous video, preprocessor directives are a part of Fortran after the introduction of C and C++. So as a consequence, you have Fortran files yeah, which allow pre-processor directives, and you have Fortran files which do not allow pre-processor directives. Okay, and usually the extension which are in lowercase do not allow pre-processor directives. Usually they do not allow, but some of them may allow depending on the case. So if we come across extensions like the F90 or F95, all of them with the alphabets in lowercase, they do not allow pre-processor directives. They do not at all. On the other hand, all the all the uppercase extensions, okay, like capital F90, capital F95, capital F, capital FTN, capital FOR, capital F77, all these allow the C based preprocessor directives. And one more cool thing about this is that you can produce the lowercase extensions from these files. If you guys look at my previous video, you guys will understand it properly. And also, if you guys look at the file that I've used last time for my previous video for preprocessor directives, it was capital F95. I use this extension, not this one. If I were to do the same with this one, it might throw an error. But this, I've used this one so it doesn't throw an error. And one more thing. Usually the fixed format files are Fortran 77. Okay, the Fortran 77 has another name for called as Fortran 1997 because this was released in 1978 because major development was made in Fortran 77. Major development was made in Fortran in 1997. So the Fortran 77 has another name, Fortran 1977. Okay, and then usually the free format files are usually advanced Fortran and modern Fortran. Now here's the distinction. Fortran 77 is actually called as legacy Fortran. Sometimes they call it, I mean at least I call it, it's like legacy Fortran. Okay, which is dot f dot f f dot f77 and dot f77. These are all Fortran 77 or Fortran 1997. These are all actually legacy Fortran files because this version of Fortran, it's like close to 97, 87, 97, 2007, close to 40 years old, but still the Fortran 77 is being used in several programming applications. So this is kind of like a grandfather to Fortran grandfather in Fortran series. So this is actually the legacy Fortran. Okay, now you don't find any programs you don't actually find a lot of developments and that are being made in Fortran 77, but it's under use because a lot of programs in the past were written in 77. They're kind of pushing it, and Fortran 77 is still faster when compared to advanced Fortran because it does not have many optimization. It does not have any user friendly operations in Fortran 77, so it's still faster. So this is actually legacy Fortran. On the other hand, advanced Fortran is actually the Fortran 1990, Fortran 90 and Fortran 95, which support little more advanced features when compared to Fortran 77, like vector operations and a little bit of pointer operations and pointer arithmetic kind of a thing. Okay, and they have two versions like Fortran 90, which came in 1990, and Fortran 95, which came in 1995. Okay, and then you have modern Fortran. There are actually three modern Fortran versions, like Fortran 2003, Fortran 2008, and there's this one more thing called as Fortran 2015. Okay, the extensions for Fortran 2003 and 2008 are F03 and F08. So if you come across any files which have an extension F03 or F08, then it means they are of modern Fortran. This is Fortran 2003 and this is Fortran 2008. And I guess if my understanding is right, the extension for 2015 Fortran will be F15 and F will be F15 if my understanding is right. Okay, and that's about how it looks. And there are actually Fortran versions that came prior to Fortran 77, like Fortran 66, Fortran 3. I guess it's Fortran 4 or something. I guess Fortran 4, Fortran 3, Fortran 2, and Fortran 1. There are like that. and those are for most practical purposes obsolete and extinct. Okay. If you guys want to know more about the history of how Fortran developed, you can just check it out. And there, they would have given a lot of more explanations of how Fortran as a language evolved through time, and how it modified, and how it became much nicely developed, and how it became a precursor for other programming languages and everything. So you can guys can have a look. Okay, but the thing is, for most practical purposes, Fortran, any Fortran Fortran version that existed prior to 77 are absolutely extinct, and Fortran 77 is the legacy version which is still being followed in certain places, and for all practical public applications right as of now, these Fortran, like the advanced Fortran and the modern Fortran, which kind of developed from Fortran 77, are the future in when compared to Fortran. And for for information like what Fortran 3 and Fortran 8 are, these are things. If you want for more details, you can go to this web page fortranwiki.org, wherein you can find these details. Fortran 2003 is actually the improvement on Fortran 95, and it includes a lot of operations like parameterized derived types. Okay, meaning you can have some constant values within derived data types, if I'm right, and you have object oriented programming developed in it, and you have operation. You can do a lot. It's kind of interoperable with C, and there are some advanced pointer thing like procedure pointers, which I have no idea as of now. There are some features available in pointers, and you can do little more of operations like command line arguments and environment variables. And by the way, if you guys want to do this kind of stuff, using pre-processor-directives will be really helpful and mandatory, and you can do a lot of changes with allocation of variables. And this is about Fortran 2003, and for Fortran 2008. It is actually Fortran 2008 has it was released in Fortran to the June 2010. Okay, and it's released, and it's yet to be implemented everywhere. They have a lot of features like submodules, meaning modules inside modules, like mini modules like that. And there are operations like there are new arrays like co arrays, which kind of like implements which kind of implements parallel programming without using parallel programming procedures. They are helpful for that kind of procedure, that kind of operations, and they help. Modern Fortran, in addition to Fortran 2003, also has options to do some concurrent programming, and there are a lot more operations like block, error, and everything to include it. And you have like some changes to the intrinsic procedures like greater than, less than, or uh, and other commands. And you have some special procedures which include some special functions like Bessel functions, error function, gamma functions, which were not before. And you have some operations like bitwise operators, which was missing in earlier versions of Fortran. They are included over here, and you have a lot of stuff over here. And you have like much more nicely developed C bindings. You have much more nicely developed C bindings which are available as a part of Fortran 2008 and everything. And as far as Fortran 2015 is concerned, it will be built on top of 2008. So all the features that are available in 2003 and 2008 will be there with much more additions. Like if you want to know more about it, you can just check it online. That will be really helpful for you guys to have an understanding of what it is. So that's all I have for you guys in this tutorial. And this is more of a demo. This is more of a lecture kind of a video, because this is you have to keep this in mind, and it's very essential. And that's about it. Thank you guys for watching, and I'll see you guys next time. Till then, take care and goodbye.